Hello algebra students. This video is on solving systems of equations using algebra, and we're specifically going to be looking at a process called elimination today. And so to start, in your note sheet you have a box that says big idea, so we're going to write down what the big idea is for these notes. And basically what we're going to be doing is we're going to be adding or subtracting two equations in a system which will create a third equation, right? So adding or subtracting two equations in a system creates a third equation that is also true. And this is going to be useful to us because we're going to be looking to add or subtract the two equations so that one of our variables will be eliminated. That's why this method is called elimination. So we can use this addition or subtraction to eliminate a variable. I'm just going to write addition, but we can we get the idea it could be subtraction. So we can use equation addition to eliminate a variable and solve a system of equations. Okay, so we're going to look at two examples and then I'm going to give you a third one for you to try. And the first example is 2x plus y is equal to 6 and 3x minus y is equal to negative 16. Well, so again, we're thinking about adding or subtracting and in order to eliminate a variable. So what I notice here right away is that I have a positive y in the first equation and a negative y in the second, which means that if I add, those will automatically cancel out because positive y minus y is going to be 0y. So the first thing we're going to do here is we're going to add our two equations. And something should cancel or eliminate. Or a variable should be eliminated. So if you don't eliminate a variable when you add, then you should go back and think about if you did something wrong. But here, when I add positive y and negative y, they cancel, so I'm left with 5x is equal to negative 10. Well, now this is my new third equation that I was talking about up there. And now this is an equation we can solve for x because there's only one variable, so I can get a value. So we're solving the new equation. So in order to solve the equation, 5x is equal to negative 10, I would have to divide both sides by 5. And I get x is equal to negative 2. So that is half of my solution, but remember a solution to a system with two variables means we have to have the ordered pair, so we need the y value. But now that I know x, it's not too hard to find y, because what I can do is I can plug back in to one of my two original equations. I can plug in negative 2 for x and solve to find y. So I'm writing, we're going to plug value back in to find the missing variable. Okay, so what this is going to look like So I'm going to use, it doesn't matter which equation we use, I'm just going to use the first one. 2x plus y is equal to 6. And then I'm replacing that x with a negative 2, because that's what I now know x is. That's going to give me negative 4 plus y is equal to 6. I can add 4 to the other side. Oh, to be consistent with my colors, I'm going to try to do this. Okay. That gives me y is equal to 10. So now I get a solution, which is the ordered pair, negative 2, 10. My fourth step we're going to do here is that we can always check by plugging in, right? And in a system, you have to plug into both of your two equations. I know it's kind of tedious, but we can do it pretty quickly, actually. So I'm doing 2 times negative 2 plus 10 and checking to see if that equals 6. And then I'm doing 3 times negative 2 minus 10, which should equal negative 16. So checking both of these, I get negative 4 plus 10. That is 6, so that one checks. And then here I get negative 6 minus 10, which is negative 16, so that one also checks out. Okay, so now we verified that the solution is in fact the point negative 2, 10. All right, let's do another example. This one is a little bit different, and you'll see why in a moment. So my next example is 4x plus 2y is equal to 26, and 2x minus 3y is equal to 25. Now, if I start by thinking about adding here, what I notice is that if I add 4x and 2x, I get 6x, and that doesn't cancel anything out. And if I add 2y and negative 3y, that gives me negative 1y, so that doesn't cancel. So in this example, there's something you need to do before you add in order to get your one of your variables to have the same number coefficient but opposite signs. So that way they would cancel when you add. And so what I notice here is that I could multiply 2x by, say, negative 2. And then that would give me a negative 4x right here, which if I added with positive 4x, that would get me to cancel. So in this one, the first step is not going to be to add like we did before. It's going to be to multiply one of the equations by something that will get our variable to cancel. Okay, and here what I can multiply by is negative 2. Now, it's important that when you multiply by negative 2, you don't just multiply the term that you need by negative 2, but you multiply every single term in your equation by negative 2. That way you know that you're preserving the equality, or you're going to get the same solution. So what this then becomes is I'm going to have still my 4x plus 2y is equal to 26 on top, but now I have negative 4x plus, be careful with your signs here, negative times negative plus 6y is equal to negative 50. Now, I'm just going to write down, before I do the next step, I'm going to write down what we just did. So, and sometimes you have to multiply one of the equations, but sometimes you have to multiply both of the equations. So here what we do is multiply to get the same coefficient with opposite signs for one of your variables. Okay, so now I'm ready to add here. So like after that, the steps go back to what they were before. So like what they were in the first example. So now step 2 is going to be to add here. And what I get, 4x and negative 4x will cancel. So I have 8y is equal to negative 24. Right? So now step 3 is going to be to solve this, right? And in this case, like in the first example, we canceled out the y, so we solved for x. But here we canceled out our x's, so now we're going to solve for y first. So I can do that by dividing both sides by 8. And I get y equals -3. From there, I can plug in to find x. I'm just kind of writing a shortened version of the steps, but you can always refer back to the first example for the whole step. Okay, so now to solve for y, doesn't matter which one we plug into, I'm going to plug into the first one. So that's 4x plus 2 times -3 is equal to 26. So that's 4x minus 6 is equal to 26. Add 6 to both sides, I get 4x is equal to 32. Then I would divide by 4, and I get x is equal to 8. So now, in this problem, then, we have y is -3, x is 8, so we can write our solution as the point 8, -3. So the last problem we're going to look at is a you-try problem, but I'm going to get you started on it. So I'm just going to flip to the next page here. And the you-try problem is 3x minus 2y is equal to 2, and 5x plus 3y is equal to 35. Now, this problem is a little bit different because the coefficient, if I look between 3 and 5, like there's nothing I can multiply 3 by to get 5, and there's nothing I can multiply, or there is something, it's just not a whole number, and there's no whole number I can multiply -2 by to get 3. So this is one of those problems where it's easiest to multiply both equations. Because, for example, if I see like -2 and 3, I could multiply the first equation by 3, the second equation by 2, and then I'm going to have -6 and +6, which will cancel. So let's go ahead and do that, and then I'm going to leave the rest of the problem up to you to solve. So what I mean is, if I multiply this first whole equation by 3 and the second whole equation by 2, and remember you have to distribute into each term, I would get 9x minus 6y is equal to 6 for the first one, and I would get 10x plus 15y is equal to 70 for the second one. Sorry, I didn't mean to write 15 right here. I meant to write just a 6. I don't know what I was looking at. Okay, so I think I was thinking about this 5, and that's why I said 15. Okay, so this is a 6. So that means that now, when you go to add here, we have this positive 6y on the bottom, negative 6y, so we know that's going to cancel. So I'm going to leave the rest of this problem up to you to solve, and we'll be discussing it in class tomorrow.